Hello and welcome to another fun-filled day in math with Mr. Sims. It's a pleasure once again to teach you and to have you do the Cycle 14 test incentive. Yes, this should be a great study preparation for your test coming up. What we're going to do today is we're going to do as many problems as we can in about 30 minutes, and we'll see what we can get done, alright? I do want to say once again that this is the least amount that you should do to study for your test. If you're studying this and you're like, oh, I'm done after this, well then that frankly is not enough, because your test has two parts in it. It has the new part and the old part, and on the test incentive videos I tend to do the new stuff more than the old stuff because I figure you've had a lot of review on the old stuff. So make sure that you are doing the study sheet as well, which covers the entirety of the test and will help you be more successful. So without further ado, let's go ahead and begin. Alexa, start a timer for 30 minutes. Alright, Alexa's got the clock running. Let's do this. Alright, so identify the following in the graph to the right. So basically, in this one here, what they want you to do is they want you to identify the graph in that particular in this particular graph here, right? They want to identify the zero and the axis symmetry. And so what I'm going to do actually is I just want to review some concepts here so that you have the most chance of success during the test. So let's say this is our axes here, right? If I had two axes that are like this, and let's say I had a parabola that looks essentially something like this here, okay? Let's just imagine, that's so ugly. I'm sorry, let me try that again. Okay, let's just say that's better. No, that's worse. Alright, so let's say that's it. Okay, so if this was my parabola here, that's a little bit better. Alright, my parabola here, the vertex would be essentially either the highest or the lowest point in the graph, right? And you can kind of think of it as the middle point of the graph in that it would go... if we went like this way, basically this is kind of like the halfway point and then it goes back up, right? So anyway, that's the vertex. It's the lowest or highest point in the graph, right? If the graph is going like this, then it would be the highest point. But if it's like this, it's the lowest point, right? Now, the axis of symmetry would be a line that goes, that cuts it literally in half. The idea being that if I folded it on that line, that all of these would match up, right? If I took and I folded this over, oh, that didn't do that. If I folded this over to the other side, it would perfectly fold over and meet on the other side, right? So that's the idea of the axis of symmetry. So once again, the axis of symmetry is a line. Notice the axis of symmetry does go through my vertex. However, it is not my vertex. The vertex in this case, let's say this vertex's coordinates were, let's say 8, comma, -1, right? If that was what that vertex was, then this line here would actually be x equals 8. And the reason why that's the case is because this would be 1, 2, 3, 4, 5, 6, 7, and finally 8, right? So here, this line is crossing the x-axis at a perpendicular. It's crossing the x-axis at 8, therefore it's x equals 8. So that'd be my equation for that line. This would be my vertex. A couple other things to notice. Notice that this vertex here is going to be a minimum. It's labeled a minimum because your graph doesn't go any below that. So this is the minimum point. This is the lowest point on the graph. Now, if a graph is going the other way, then it's going to be a maximum point on the graph. The vertex would be a maximum point, all right? So you get the idea a little bit of those things. So once again, we've covered that. Your zeros are going to be the places where they touch the x-axis, okay? So I've basically defined a lot of terms for you, right? I've defined the axis of symmetry, I've defined the vertex, I've defined the x-intercepts, also known as the zeros, x-intercepts, zeros, roots, solutions, right? All of these are basically the same exact thing, they just mean x-intercepts. So now that we have the vocabulary, we're not kind of shooting in the dark at this, so let's go ahead and look at it now. Let's look at this graph. So this graph says they want us to identify the following on the right. They want us to identify the zeros. Remember, I said earlier that your zeros are your x-intercepts. So if your zeros are your x-intercepts, I'm looking at this graph and I'm asking myself the question, where does it cross the x-axis? Well, this right here is the x-axis. The reason I know this is the x-axis is here's my y values, and this is 1, and then finally this one would be 0, right? So this would be the origin, 0, 0. And so your x-axis always goes through the origin, or to put it a different way, when you're on the x-axis, your y value would always be equal to 0, because your x-axis really is y is equal to 0, okay? So anyway, all that to say that in this case here, this line never actually touches the x-intercept. So when it's asking for the zeros, the answer is, well, in this case, there's none. There are no zeros. Bummer. Axis of symmetry. The axis of symmetry in this case, it looks like this is the line that would split it right in half, right? And that line looks like it goes through 4 right there, right? So this line then, it goes through 4 and it crosses x, so it's going to be x is equal to 4. And I'm going to take the time to tell you that in Algebra 1, all of our parabolas in Algebra 1 go either up, either open up, or they open down. Like, so they either go this way or they go this way. So because of that, all of our axis of symmetries are all going to go up and down. They are never going to go this way, because to have an axis of symmetry going that way, you need a parabola that goes like that, and we won't deal with those in Algebra 1. So in Algebra 1, whenever they ask for the axis of symmetry, it's always going to be x equals. Now that is once again only true for Algebra 1. So axis of symmetry, x equals, and in this case x equals whatever value it crosses the x-axis at, which is 4. So x equals 4. So there's my answer. There's no zeros, and x is equal to 4. All right? Going to go ahead and move on to the next one. Ding! Which of the following correctly describes the axis of symmetry? So here, once again, we're looking at the axis of symmetry, and the axis of symmetry looks to me like it's right there. So once again, it crosses the x-axis at a value of, it looks like -4. So as I told you, in Algebra 1, all of our parabolas are going to have x equals -4, all right? Okay, now once again, this is only true in Algebra 1, because later on, once you get to Algebra 2, you'll be dealing with conics and stuff where the graphs will be rotated. Like basically, you'll have parabolas that open to the left and the right. Okay, but for now, that'll suffice. All right, let's go ahead and do this right here: quadratic, parabola, axis symmetry, and vertex. And what they want us to do is fill in the blanks with each of these, right? So it looks like the first one, something is the shape of a quadratic equation. Well, the parabola is the shape of a quadratic equation. So I'm just going to go ahead now, and I'm just going to put in parabola. The parabola, right, is the shape of a quadratic equation. All right, I'm going to see if I can't move that into the line. There we go. All right, so there's that one. Then it says the highest or lowest point of a quadratic equation. Well, I've already used parabola, right? So now I'm looking at the highest or lowest point in a, sorry, I have to change something real quick, in a quadratic equation. And that's going to be the vertex. The vertex is your highest or your lowest point. So I'm going to go ahead and put that in as well. Let me go ahead and write it there. The vertex. Okay. All right. The next one says an imaginary line. Sorry, let me just move that line. An imaginary line that cuts a plane. Oh, what on earth happened there? Oh boy, I didn't mean to do that. Let me try that again. All right, vertex. Okay, vertex. There we go. Gonna put that in place. There we go. Now it's perfect. All right, so that's the vertex, right? And then I'm going to go ahead and answer the next one. An imaginary line that cuts a plane or a figure into two congruent halves. That's going to be the axis of symmetry that we've been talking about so much. So I'm going to go ahead and put that in place now. Axis of symmetry. Axis of, whoops. Axis, can't type tonight. This is going to be fun. Axis of symmetry. I'm going to abbreviate that. You don't abbreviate on the test. I ran out of room. You can adjust your handwriting more easily than I can. So you write it correctly. There we go. All right, axis of symmetry. Now, a function that can be written in the form ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0, is called a quadratic. All right. So that's a quadratic, and we could go ahead and put quadratic in there as well. So let me go ahead. All right, quadratic. All right, without further ado, I'm going to go ahead and move on to the next question, but you got the idea. Awesome. Pardon me, I did not mean to sneeze on the mic, but that happened. All right, so I have that now. All right, moving on to the next question. Next question. It's the most wonderful question. Here we go. Solve the following system of equations by elimination. Have you been wishing you could do this all your life? Well, congratulations. Now you can, because in this one, this system of equations, remember, when we're solving a system of equations, what we're really trying to do is, if we were to graph both of these lines, there's going to be some point, unless they're parallel lines, there's going to be some point that they intersect. And when we find a solution to a system of equations, or we solve this system of equations, what we're trying to find is that one point right here where they meet. Okay, so that's what we're trying to find. So in this case here, I have 9x plus 5y is equal to 14. Negative 9x minus 10y is equal to negative 19. And what I want you to do is I want you to think about with me for a second what I call the strength of the numbers. And I'll explain that here. It's what I call the strength of the numbers. And the strength of the numbers, what I mean by that is this number here is 9 strong. I'm kind of talking about the absolute value of it. I call it the magnitude because I take that from like physics classes and stuff in vectors. But this really has a magnitude of 9, and this also has a magnitude of 9. Now they're going in opposite directions, right? This one's negative and this one's positive. But what I mean by that is they both have this kind of like a strength of 9, you could think of it. I'm going to call that magnitude, all right? So when you're looking at these, if there's a variable, like this is x and x, that has the same magnitude, even if the numbers are negative and positive, as long as the numbers are the same strength, like 9 and 9, then I'm able to cancel those out by either adding or subtracting the equations. So I'm going to go ahead and do that now, because what I really want to do is try and get one variable. That's my goal. My goal is to knock out one variable so I can solve the other variable. So I have to ask myself the question, what would make 9x and negative 9x go away? Would it happen by me adding, or would it happen by me subtracting? So you could really think of it, if I had 9 and I had negative 9, if I added those two together, wouldn't they cancel out? Yeah, if I, in fact, subtracted them together, right, if I tried to subtract them from each other, 9 minus a negative 9 is really going to be 9 plus 9, right? If you think about it, if you minus a negative 9, you're adding 9, that'd be 18. So that didn't accomplish what I wanted. So I did not want to subtract. I instead want to add. So I'm going to add these two equations here, and I'm going to show that by putting an addition. And I like to circle my addition so I don't get confused with other negative signs. I now have 9x plus a negative 9x, so these are actually going to cancel out. 5y plus a negative 10y is going to really be 5y minus 10y, right? Which is negative, that's going to give me negative 5y. And that's going to be equal to 14 plus a negative 19, which is going to end up being a negative 5. So I have negative 5y is equal to negative 5. As you can see, my x's have dropped out now, so I can solve for y, which is what I want to do. I'm going to do that by dividing by negative 5 and dividing by negative 5. And I get y is equal to 1. So when you have y is equal to 1, at this point, I have half of my answer, but I don't have my full answer. And I want my full answer because what I've done is I basically said this. I basically said, all right, if this is my coordinate grid, right? What I've said is I have an answer that is somewhere on y equals 1. So here's y equals equal to 1, right? And here's the line that would make, I'm going to make it blue. The line that would make it y equals 1 is this line right here. And what I've said is I have two lines, and somewhere on this line, they are intersecting right on, sorry, pretend that is, let me try that again. So somewhere they are intersecting right on that, right at a point, right? This is the point here that I'm looking for. So I'm looking for this point right here. Now, what I've said by solving for y is equal to 1 is that it lies somewhere on this line, right? But in order to know exactly that point, I need this x value to lock that point down. So now what I'm going to do is I'm going to plug that y in so I can get my x value. So I'm going to plug that y in. I'm going to go back to my original color. Let's go to that one actually. So I'm going to plug that y in. I'm going to use one of my original equations. You can choose either equation to use. I'm going to choose the one that I like. This one has a lot of positives. I don't have to deal with negatives. So I'm going to use that because just like you, I am more prone to make mistakes if there are negatives. So I try and avoid them if I can. So 9x plus 5y is equal to 14, right, is the one I'm going to use. And I'm going to plug this y equals 1 in for y, right? So not this one here, sorry. 9x plus 5y. And so, here we go. I don't want to do that either. Okay. So I got 9x plus 5y is equal to 14. I'm going to plug in. I got 9x plus 5 times 1 is equal to 14. So then I get 9x plus 5 is equal to 14. And I'm going to subtract 5 from both sides. Right? Subtract 5 from both sides of the equation. These cancel out, and I get 9x is equal to 14 minus 5, which is 9. So I have 9x is equal to 9. I divide by 9. And I get my x value is 9 over 9, which is 1. So I now have x equals 1 and y equals 1. So if I put that into an into my ordered pair, it's going to be 1, the x value first, then the y value, 1. So it's 1 comma 1. All right, let's go ahead and move on to the next one. We've had some great stuff so far. Let's go to this one. Solve the following system of equations by elimination. All right, so let's go ahead and do it. All right, so at this point now it says solve the following system of equations by elimination, and I'm going to show all my work because they want me to. And let's go ahead and start with it. So I'm going to ask the question like I did last time. The question that we asked was, which one of these has the same strength, right? I was talking about that strength of the numbers, right? And so negative 3, these have like a strength of 3 and a strength of 4, right? And they're both going in negative directions. That actually right there, they don't have the same one. This one has 5 and 10. Now, unfortunately, none of them have the same strength right off the bat. None of them have the same amount of strength. And so I'm looking now and I'm asking myself the question, is one of these one that I could change to have the strength of the other one by multiplying it easily? In other words, this 3, to get to 4, I'd have to multiply it by 4 over 3, like a fraction, 4 thirds. If I multiply 3 times 4 thirds, right? 3 times 4 thirds, right? The 3's cancel out, and then I would have 4. And 4 would match in strength to this 4 here, right? So I could do that. I could multiply this whole equation by 4 thirds. But I think you're with me. You don't want to do that. So let's look at this one instead. This one has has 5, a negative 5, and this one has this one has a strength of 5. This one has a strength of 10. Is there anything I could do to get from a strength of 5 to a strength of 10? And the answer is yeah. I could take 5, multiply it times 2, and then I'm going to equal that 10 strength that I'm looking for. Does that make sense? So that magnitude of 10 that I'm looking for. So what I have here is I have the negative 3x minus the 5y is equal to 6, and I'm going to multiply the whole equation by 2, because I can't just multiply this alone. I have to multiply the whole thing by 2 in order for it to stay a valid equation, right? So now I have to distribute in this 2. I'm literally going to multiply it times every term in there. So I get 2 times negative 3x is negative 6x, right? 2 times negative 5y is going to be negative 10y. 2 times 6 is equal to 12. Then this is negative 4x minus 10y is equal to 8. And at this point, you can see that now these strengths match up, right? I have the negative 10 and the negative 10. And in fact, not only do they match up, these are exactly the same. So I need to ask myself the question now, how do I get, if I want these to cancel out, how would I accomplish that? Am I going to add or am I going to subtract them? So I want you to think real quick. If I had negative 10 and I subtract, or let's say I add negative 10. If I add negative 10 and negative 10, I'm going to get negative 20. And that's not what I want to get. I want them to cancel out. So let's say instead of adding, I subtract that negative 10. Well, if I subtract that negative 10, what I'm really getting is negative 10 plus 10. Because if you subtract a negative, you're adding. So negative 10 plus 10 cancels out to 0. So that's actually what I want to do. I want to subtract in this case, right? So I want to subtract both my equations, and that's that way those will cancel out, right? So let me start with the negative 6x. Negative 6x minus a negative 4 is really negative 6x plus 4, right? Because if you minus a negative, you're adding. So negative 6x plus 4 is going to be negative 2x. So I get negative 2x. Negative 10y minus a negative 10y is going to be negative 10y plus 10y. These cancel out then, right? These 10 y's will cancel out, negative 10 y's will cancel out. And then 12 minus 8 is 4. So now I have negative 2x is equal to 4. I'm going to divide by negative 2 because I want to get x alone, right? So I divide by negative 2 because it's being multiplied by negative 2. And I get x is equal to negative 2 because 4 divided by negative 2 is negative 2. So x is equal to negative 2. Great. Now, I am only half done. I need to go ahead and place that back into another equation. Now, you do not want to use this equation here that you got by multiplying. You want to go back to the original equation, okay? So I could go back to this original equation, or I could go back to this original equation. And really, you do whichever one you like best. I'm going to go ahead and go with the first one. They both look pretty ugly to me. So I'm going to go ahead and go put it in for negative 3x. Sorry, my computer froze on me for a sec. Negative 3x minus 5y is equal to 6. Now that I have that, I can plug in that negative 2 for x, so I get negative 3 times negative 2. All I did here was I rewrote the equation just to make sure I plugged it in the right place. Minus 5 times my y, I don't know my y, is equal to 6. So in this case here, I got negative 3 times negative 2, which is a positive 6. I have 6 minus 5y is equal to 6. I'm going to subtract 6 from both sides. These cancel out, and these cancel out actually. So I now get negative 5y. If these cancel out, 6 minus 6 is equal to 0, right? So negative 5y is equal to 0. Divide by negative 5, and divide by negative 5. And I get y is equal to, what is 0 divided by negative 5? This actually stumped a lot of my students earlier. So let me talk about it. If you have nothing, and you split it into 5 groups, how much is in each group? Well, nothing, right? If you have 0 and you divide it by anything, it's 0. And if you don't trust me on that, you can use your calculator to figure that out yourself. But it is, y is equal to 0. So now I have x is equal to negative 2 and y is equal to 0. And I have to put it in this form for it to be my final answer, okay? Ding! All right, I'm done with that one. Let's go on. What is the solution to the system of equations graphed below? So the solution is where these are going to meet, which to me looks right there. So if I were to look at that closer, I would see that at that point, let's read the graph first, because honestly, I'm not even sure what this is about. Fantastic Fit Gym membership plans. Okay, so this is looking like some type of membership plan, and it's looking like this is the cost that the plan is going to cost you, right? This is the number of months. So it looks like if you're like at 1 month, if you're paying for 1 month, that the veterans plan is actually going to be cheaper than the beginners plan, right? However, later on, like at 11 month, the veterans plan is actually going to be more expensive than the beginner's plan, which is interesting. I don't know why that would be. But anyway, moving on. I'd have to think about why that would be. Anyway, but moving on. Here we go. So here's your intersection point, right? And that intersection point is what I'm looking for because that's my solution. Your solution is where the two lines intersect. So my x value is 4. My solution really is 4, comma, 100. But it doesn't look like they just want the value. It doesn't look like they just want the solution. Sorry, let me write that a little bit neater. 100. So it's 4, comma, 100. It sounds to me like they want a little bit more context in it. So they want to make sure I understand what I just solved. So what this is remember that 4 is really 4 months. So it's saying at 4 months, the cost will be $100. So at 4 months, the cost will be $100. And truthfully, that will be $100 for both plans. So at 4 months, they will both cost the same amount at $100. All right. That's, once again, in context. Here we go. Solve the following system of equations by elimination. Alright, so continuing now, solve the following system of equations by elimination. So we've done a couple now. Once again, this example here, I'm going to ask the question, are there any variables that have the same kind of strength to them or the same magnitude to them, right? And this one here, if I look, the 2y has the same exact magnitude. In fact, they're the same exact thing. So I can get rid of them easily. I I can get rid of them easily by subtracting, right? Since they're exactly the same thing. If they're the same, you subtract. If they're opposites, you add, right? So I'm going to subtract 2y minus 2y. These are going to then cancel out. 4x minus a negative x is really the same thing as 4x plus x, right? And so the 4x plus x is going to be 5x, which is equal to 12 minus 2, which is 10. 5x is equal to 10. I'm going to divide by 5, divide by 5, and I get x is equal to 2. And that is half of my answer. Once again, I need to then plug that into something. And I'm going to choose to plug it into... This one doesn't have any negatives. I'm going to go with that. So I got 4x plus 2y. Once again, negatives do make you more prone to get a problem wrong. So if you can avoid a negative, if you have a choice, it's sometimes a good way to a good thing to steer away from them. Okay, but it's also even better to learn how to deal with them and know how to do them well. But for your benefit, I'll do it with the regular one here. So 4 times 2 plus 2y is equal to 12. So once again, I plug that 2 in for x, which is why you see it here. So that becomes 8 plus 2y is equal to 12, right? I'm then going to subtract 8 from both sides to get this y term alone. I subtract 8, which gives me 4 is equal to 2y divided by 2, divided by 2. Got lots of things for me and you. Here we go. We got y is equal to 2. And I got x equals 2, y equals 2. So now I'm just going to put that in an ordered pair. Now it's this 2 here comes from my x, right? Very important. This y goes second, comes from this 2 here. So this one ends up being 2 comma 2. All right, let's continue. For a given arithmetic sequence, f of 5 is 6 and f of 7 is 12, which rule defines the sequence? So what it's saying here is it's saying that there's a sequence where you have 1, 2, 3, 4, 5 terms, where the fifth term is 6, right? And you have 6 terms, 7 terms. So once again, this is f of 1. This would be f of 2, 3, 4, 5, 6, and finally this would be f of 7. And they want to know what our rule is. So f of 5, it tells me is 6, right? F of 5 is 6, so I put 6 there for f of 5, right? This is my f of 5. And then for f of 7, I put 12 because this is what they want us to put for that, okay? And which rule describes this sequence? So if I'm looking at this, I need to figure out what f of 1 is first, what f of 1 is going to be. But in order to figure out f of 1, I need to figure out what are my jumps. Well, if the jump from 6 to 12, right, is really plus 6, I really need to recognize that it's not just one jump. Technically, it's actually 2 smaller jumps. So if the gap is plus 6 there, then how much is each individual gap? Each individual gap then would be plus 3, right? And plus 3, which means that 6, f of 6 would be 9, right? And as you can see now, if I'm adding 3 for each of these jumps, then going backwards, I would be subtracting 3. So this would be 3, and this would be, what would this, 0, and this would be negative 3, right? I'm sorry, negative 3, right? And then this one would be, if I subtract 3, would be negative 6. So negative 6 is my first term, right? F of 1 is equal to negative 6, which is either J or G. And it looks like my rule is negative. My rule each time is this plus 3 here, right? Remember, plus 6 was this big, massive jump, but my individual jumps are each plus 3. So my rule is plus 3, right? And my first term is the negative 6. So the correct answer is G. This one, although it has a first term of negative 6, the rule is plus 6, which was the jump from to 2 spaces. But I need each individual jump. So that's why the answer is G and not J. All right, let's go ahead and see if I got a little bit more that I can do in the time that I have. All right, so 4 expressions are shown below. The expression 4x squared minus 4x minus 120 is equivalent to, the question is which one is it equivalent to? So, huh. Okay, so this is the expression I have. 4x squared minus 4x minus 120. And what I have to do basically is this. I have to take each of these and I have to multiply them out to see which one matches. This is actually going to be a pain in the bottom. I'm really regretting choosing this problem. I'm just kidding. So minus 4x minus 120. But it is going to take some work. So the first one is just a simple matter of distributing, right? So that's going to be, if I distribute there, it's going to be, let's see, for answer choice 1, it would be 4x squared minus 4x, right? Because 2 times negative 2x is minus 4x. 2 times negative 6 is going to be minus 120. So you can see that these two, this is what it needs to be equivalent to. And is that equivalent to that? The answer is yes. So 1 is definitely equivalent to it. So if it doesn't have 1, I can automatically knock it out. That one doesn't have 1, nor does that one have 1. Now I want to save myself a lot of work. I don't want to do all of these if I don't have to. Like doing 2 is pointless because they both have 2. So doing 2, I can assume it's going to be correct, right? That they're both going to equal that, right? The one that they differ in is this 4. So this is the one I need to do. I need to do this 4x times x minus 1 minus 120 and see are they equivalent. So I'm going to take that 4x now. I'm going to distribute that in. So I get 4x squared, right? 4x times x is 4x squared. 4x times the negative 1 is negative 4x, right? And then I have the minus 120 at the end. So 4x squared minus 4x minus 120, it matches what it's supposed to match. So 4 is also one that matches. Now notice, because I was actually just a little bit smart about how I did it, I actually had to do a lot less work. I only had to do 2 of these, right? So always try and think so that you can work a little bit smarter, not harder, all right? So you got the 4x squared minus the 4x minus 120. So 1 and 4 also, since 4 is also equivalent, then I know my answer must be C. A should have 4, and it does not. It does not have the IB. All right, let me see what I got here. Factor this trinomial. So if I factor this trinomial, I'm going to use the x method here, right? Remember, in the x method, you have on top, oh, there's Alexa, so the last problem I have time for. So a times c, on the bottom is going to be b. Alexa, stop the timer. So a times c, right, 5 times 15 is going to be 75. The b is negative 28. So I'm looking for two numbers that multiply to give me 75, but they have to add to give me negative 28. So I'm going to start making my factors of 75. Obviously, there's 1 times 75, but those don't add to give me negative 28. We're like 1 plus 75. Oh, and actually, I almost made a mistake there. I need two numbers that multiply to get negative 75, but they have to add to get negative 28. The only way they get the only way they multiply to get a positive number but add to get a negative number like that is if they're both negative. So I need to look at that I need to factor that in when I'm doing this. So anyway, so negative 1 didn't work. Let's see, negative 2 doesn't work. How about negative 3? Negative 3, it would be times negative 25 would equal 75. And negative 3 plus a negative 25, right, equals a negative 28, which is what I needed. So this is the correct answer. This negative 3 times a negative 25. So I'm going to go ahead and put my negative 3 here and my negative 25 here. I'm going to write my negative 3 right here and my negative 25 right here. And what I'm going to do is I'm going to bring down, once again, the whole point of doing all of this x was just to split up this term here into two terms that are going to work for factoring. That's the whole point of doing all this. Frankly, if there was an easier way, we do the easier way. This is it. So we're going to take and we're going to bring down these things here. All right, and so that's going to be 5x squared, 5x squared minus 3x, right? That minus 3x came from right here, right? Then it's going to be minus 25x. And finally, plus 15. All right, so now that I have both of those, like that, I'm going to ask myself the question, what can I factor out of this one here? And the only thing I can factor out of this one, unfortunately, is an x. So I'm going to take out the x there. So the x comes in the front of the parentheses. And I'm left with 5x minus 3. Now, because I have this 5x minus 3, that is what I'm trying to get here. So I'm going to let that decision help guide me in what I need to pull out here. And it looks like if I want to get 5x here, then I need to take out a 5 at least, but I also need to take out a negative, because this is negative 25x currently. So if I divide this by negative 5x, and I want to get negative 3 here, so I'm going to once again divide this by negative 5, right? Because I'm taking it out of both of them. Then I pull that negative 5. Oh, sorry, not negative 5x. That was I mistakenly said that. So divide by negative 5. So I pull that negative 5 out front, and I'm left with 5x minus 3. Now, because these 5x minus 3's match up, I can do this where I take the outsides, and the outsides join together to become one factor, which is x minus 5, and the insides join together to become the other factor, which is 5x minus 3. All right? So, actually, yeah, so that's it. That's the factoring. Now, just so you know, one of the ways they love to ask it on the STAR test is this. They love to say, hey, which of these is one factor of it? And so what they'll have is they'll have A, B, C, or D. And the reason they do that is they don't want you to be able to FOIL the answer, right? If you could FOIL the answer, then you could work backward without having to factor. So what they'll do is they'll put like the answer choice and say 5x plus 2, 5x minus 3, right? X plus 4, x minus 2, and they'll say which of these is a factor of this equation here. And then you have to realize, okay, 5x minus 3 is one factor, and you do that by factoring, okay? Anyway, it's been a pleasure. We've gone through a lot tonight. Basically, we talked about parabolas, and we talked about quadratics and what they look like and the different components of them, right? We talked about the axis of symmetry and how you find it. We talked about just some different vocabulary: parabola, vertex, axis of symmetry, quadratic. We talked about how to find solutions of systems of equations and how you need the two parts of it and basically what it looks like, right? We did some systems of equations solving. And finally, we also even touched back on arithmetic sequences, which are sequences where you add to get the next one. So we had a lot of fun tonight. I hope that you learned a lot in it. Please make sure to, once again, remember that this is just the tip of the iceberg of your studying. If this is all you're doing for studying, I'm going to be honest with you, you're not doing enough. I'm glad you're doing this, but you can do more. And that more is the study sheet. Once again, with the study sheet, get that 100 that you're looking for. You can totally do it. Don't forget, we are always available to help you check answers on the study sheet. If you're wondering if you got it right, we can help you with that. We're glad to help you with that because we love to see someone who's actually doing what they're supposed to do to be successful in our class. And so anyway, I wish you the very best. Thank you for all your effort. You guys are totally amazing. Oh, I forgot to tell you what to draw. So here's what I want you to do. In the bottom right-hand corner, say Mr. Sims forgot to tell us what to draw. You can write that in the bottom right-hand corner. Mr. Sims forgot to tell us what to draw, all right? And then in the upper left-hand corner, I want you to draw a starfish, okay? Just draw a starfish. You can try to draw SpongeBob's starfish, that starfish friend he has. I don't know what his name is, but yeah, feel free to draw him. All right, I wish you guys the very best. You are amazing. Thank you so much for all the effort that you give. I hope that you have a wonderful, wonderful, wonderful testing experience. Have a great day.